Hello, this is Daniel Tamayo, and I'll be talking about gold and the mining and manufacturing processes associated with it. Gold is the 79th element in the periodic table and is a highly sought after metal throughout the course of human history, primarily for its color and luster, but also for its high conductivity of electricity. Gold has been the standard for its practice in currency, jewelry making, and electronic production. Regarding gold ore, a majority can be found in its natural gold form, often embedded within hard rock or quartz in small particles. Here we can see the different types of ores found. They come in a plethora of different formations, generally in sedimentary rock, making up about 70% of the gold ores mined. An additional 20% of gold can be found in the form of tellurides, which is a telluride rock, or sometimes called a calaverite containing gold deposits. The remaining 10% is in the form of microscopic gold particles found in crystalline structures, often called invisible gold. When checking for the quality or grade of gold concentration in ores, a process called fire assay is utilized and is considered the most reliable method for testing. Ore samples are crushed and placed in a crucible containing lead oxide, silica, borax, and flour. Once heated in a furnace, the molten mixture will leave gold and metal deposits that sink to the bottom, while excess waste is formed at the top as slag. To extract the gold, a process called cupellation is used, where the metal sample is heated to 850 degrees Celsius in a cupel. The cupel is a porous ceramic container made of calcium phosphate that absorbs the lead as it oxidizes, leaving behind small droplets of gold. As of 2021, the largest gold mines in the world can be found in the Nevada gold mines in America and the Muruntau mines in Uzbekistan, both producing about 3 million ounces of gold. The remaining top mines produce over 13 million ounces of gold, or 12% of all gold produced in 2021. Focusing on the Nevada gold mines, it is a joint operation of several mining facilities along the northeast region of Nevada. Here, gold ore is extracted through a combination of open pit mines and underground mining operations. Open pit mines remain their largest operation, and the gold ores are extracted using excavators and are sometimes blasted, depending on the gold veins and ore placements. Large dump trucks then transport the ore to be separated and processed. For the underground mines, a suitable mining area is first surveyed, then the tunnels are drilled into. As the gold ores are mined, samples are first tested for their quality and grade before more tunnels are dug. After drilling, large chunks of rock are blasted and the fragments are removed using excavators. Additional support structures are installed as the mines are dug further and deeper. Careful attention must be placed to ensure that the mines would not collapse under continued workloads and stresses. The processing of gold can be broken down into 4 separate steps: preparation, mixing, leaching, and collecting. In the preparation stage, the gold ores are fed into several crushers and grinders to further separate the ore from other rocky materials, turning these samples into smaller and smaller pieces to assist in the upcoming stages. If more crushing is required, some mines will utilize mills with additional crushers and grinders, while water is flushed in to create a slurry mixture. This slurry is pumped into a primary cyclone, which then allows the denser rock materials and waste to sink. In the mixing stage, the slurry is treated with sodium isobutyl xanthate, which allows the gold particles to bond with the sulfur found inside the rock deposits. This process is utilized to compact loose gold particles and help further separate the gold ore from the rock waste with an estimated 70% success rate. Collectors found near the end of the line are also used to catch the remaining 30%. This process is repeated several times depending on the grade and quality of the ore mined, and any waste from the slurry is first neutralized and then separated at the end of this process. The next stage utilizes a process called dump or heap leaching, wherein a sodium cyanide solution is used to dissolve the gold into a liquid. The gold is ran through the line of several tanks filled with the sodium cyanide solution, and this process can take several days to finish as the solution slowly dissolves the gold. A higher concentration of the solution is added to the start of the line, while a more diluted solution is found near the end. A stream of activated carbons is used at the end of the tank system to collect the liquid gold from the slurry, and an estimated 98 to 99% of the gold is collected at the end of this process. Once the carbons are full, they are transported to a gold desorption area used to wash the activated carbons and golds from the cyanide and other waste. This is then fired in a furnace wherein the molten gold sinks to the bottom while the rest rises to the top as slag. The gold left behind is formed into a bar and samples are sent out to be inspected. Two main uses for gold can be found in the jewelry making and electronics industry. The shiny luster and color of gold lends itself well in the world of fashion and jewelry, especially for rings and bracelets. In the case for golden rings, casting is often the preferred method for manufacturing. The initial step is first creating the ideal ring design that the customer is satisfied with. Usually a wax replica of the ring is carved according to the desired measurements and specifications of the customer. Once the wax replica is finished, it is attached to a wax stem and then encased in a small container filled with plaster. The container is placed in a vacuum chamber to make sure that no air bubbles will form on the inside, as any air can cause imperfections during casting. The container is then placed in a furnace to allow the wax ring sample to melt, and the wax stem also acts as a channel for the gold to flow into. Before casting, the grade of gold is first chosen. Gold is measured in the standard of carat, wherein pure gold is equal to 24 carats. Often the gold is combined with other metals or alloys to strengthen the jewelry, but lowers the quality or carat of the jewelry. The three most commonly used types of gold are white, yellow, and rose gold. White gold being a mixture of gold and nickel and electroplated with rhodium. Yellow gold is a combination of gold and zinc, and rose gold is the combination of gold, copper, and silver. For the method of casting, many jewelry makers utilize a centrifugal casting machine, where the molten metal is spun around a circular axis balanced by a counterweight. The plaster contained is first placed into the end of the centrifugal arm, where the open channel is faced towards the pouring bin. The molten metal is then poured into the bin and the machine spins so that the molten metal is forced into the ring mold. After some time, the metal hardens and the mold is placed into water to dissolve the hardened plaster and extract the ring. Oftentimes, additional work is required to keep the ring in the desired shape, and a series of buffing wheels is required to polish the ring to its desired finish. For electronic components, gold is used for its high conductivity, but also for its high resistance to corrosiveness and rust. One utilized method was to electroplate certain electrically sensitive components, such as the end of connectors or the pin beds of computer CPUs. For cables such as HDMI and display ports, only the end connectors are electroplated, as they are the components that are the most exposed to outside elements. CPUs utilize hundreds of small pins to connect to motherboards, and each pin is gold-plated for a secure connection and protection from electrical shorts. When electroplating gold to different components, careful preparation is necessary. The component is first cleaned of any manufacturing debris or dust and thoroughly polished. Sometimes additional stages of cleaning are required, such as electro or ultrasonic cleaning, to remove any oils or scratches on the surface. The bath used in electroplating consists of a electrically conductive fluid, in this instance water, and a metal salt. Metal salt is what will be used to plate the components and is created from the reaction between a metal, and in this case gold, and an acid, usually a mixture of hydrochloric and nitric acid, usually in a 3:1 ratio. For certain components, a base layer may be necessary before gold plating. Similarly to how primer can help paint adhere to certain surfaces, a base layer of nickel plating is used to improve the bonding of gold plating, or to prevent certain metals from reacting to gold, such as copper. This base layer or strike layer is also helpful in prolonging the durability of the gold electroplating. The next process, a stainless steel rod, is used as the anode or the positive lead and is placed in a container holding the bath mixture with a plating voltage of around 4 to 8 volts depending on the size of the component. The mixture is heated to around 110 degrees Fahrenheit, and the electronic component is suspended in a cathode bar or the negative lead in this process. The sample is submerged in the bath for 30 to 45 seconds depending on the size and plating thickness desired. In this process, the positively charged gold ions will bind to the negatively charged components, completing a full plating layer. Additionally, a spindle may also be used to help agitate the bath mixture to help with the plating process. And once this process is finished, the components are given a final rinse, then dried before testing.